So why is configuration hard to get right? First, it's difficult to define what we mean by correct behavior in the first place. Second, the interactions between multiple routing protocols can lead to unpredictability. Furthermore, each autonomous system on the internet is independently configured, and the interaction between the policies of these autonomous systems can lead to unintended or unwanted behavior. The third reason that configuration is hard is that operators simply make mistakes. Configuration is difficult, and network policies are very complex. Furthermore, network configuration has historically been distributed across hundreds or more network devices across the network, where each device is configured with vendor-specific low-level configuration. We'll see in the first part of this course how software-defined networking, or SDN, changes this by centralizing the network's configuration in a logically centralized controller. At a very high level, software-defined networking provides exactly the primitives that operators need to run the network better. In particular, SDN provides operators three things. The first is network-wide views of both topology and traffic. The second is the ability to satisfy network-level objectives, such as those that we talked about before, including load balance, security, and other high-level goals. The third thing that software-defined networking provides that network operators need is direct control. In particular, rather than requiring network operators to configure each device individually with indirect configuration, SDN allows an operator to write a control program that directly affects the data plane. So rather than having to configure each device individually and guess or infer what might happen, software-defined networking allows a network operator to express network-level objectives and direct control from a logically centralized controller. So to make network operations easier, routers should forward packets, since router hardware is specialized to forward traffic at very high rates. They should collect measurements such as traffic statistics and topology information. But on the other hand, there's no reason that a router should have to compute routes. Although conventionally routing has operated as a distributed computation of forwarding tables, the computation doesn't inherently need to run on the routers. Rather, the computation could be logically centralized and controlled from a centralized control program. This logical centralization is the fundamental tenet of SDN. So a simple way of summing up software-defined networking is simply to remove routing from the routers and perform that routing computation at a logically centralized controller. Now, of course, SDN has evolved to incorporate a much broader range of controls than simply routing decisions, and we'll talk about the range of control that SDN controllers enable in today's networks throughout this lesson.